Okay, in the last video we looked at solving a system of equations using the substitution method where we substituted something in. I'm going to show you now what we call the elimination method. Now, eliminate or to eliminate something means to remove something or to get rid of something. And in this case, what we want to eliminate is a variable. Okay, so we'll start with an example. If we have, for example, let's use a black pen, 2y plus x equals 40 and 2y minus 6x equals 12. Okay, so again, this is what we're going to call the elimination method. We have equation 1 and equation 2, all right? Now, to eliminate something from this, you can see here that we have 2y and 2y. Okay, they're the same. So what we can actually do is we can simply draw a line underneath them and do a subtraction here. So we're going to do equation 1 minus equation 2. So if we do 2y minus 2y, there's now 0 here. So there's nothing there anymore. That's gone. Okay, and this is where you need to be a little bit careful, because if you do x minus negative 6, it becomes x minus negative 6x, it becomes x plus 6x. So we end up with 7x here is equal to 40 minus 12, which is 28. Okay, now our next step is to just divide by 7. Okay, so we get x is equal to 4. All right, we have found x. All we then need to do is substitute this x value back into one of our equations. I like the look of the first one because they're all positive. Looks nice and neat. So we have 2y plus x, which is 4, equals 40. So we're going to minus 4 from both sides. We will get 2y is equal to 40 minus 4, which is 36. If we then divide by 2, we get y is equal to 18. So our ordered pair here is 4 for x and 18 for y. Okay, this is our solution. All right, so this elimination method is, pretty nice. Okay. Much quicker than using substitution, but you do have to be careful, especially when you have a double negative like this. All right, what we're going to do is, in the last video, we did this example here. So I'm going to show you with this example here just how much faster it is to do this method. Okay, you can compare it to the other video if you like. So in this example, we have equation 1 and equation 2. And you can actually see that we can't eliminate anything simply by subtracting, okay? There's nothing we can do here that will immediately eliminate something. So what that means is, before we do any subtracting, we're going to need to multiply the second equation by something in order to make these variables the same. Now, it doesn't matter whether you want to eliminate x or y. You can choose. In this case, x is first. So I'm going to do 5 times everything. All right, and then eliminate the x. Okay, so equation 2 is going to become 5x plus 5 times y, which is 5y, is equal to 5 times 4, which is 20. All right, and this is now equation 3. Okay, what we're going to do now is, we've got this annoying one in the middle, but we're going to do equation 1 minus equation 3. Okay. And that's going to give us our answer. Okay, so 5x minus 5x, that's gone. 7y minus 5y leaves us with 2y. And 32 minus 20 leaves us with 12. Okay, we can divide by 2 here. 2y divided by 2 is y. And 12 divided by 2 is 6. Okay, so we have a y value. Now we need to substitute that y back into an equation. In this case, I think equation 2 is the easiest. So we have x plus y, which was 6, equals 4. all right, minus 6 from both sides, x is equal to minus 2. So in this case, our ordered pair is minus 2, 6. And that is what we got for the previous video. So you can see that this is a pretty nice method. There's a couple of little things where you do need to be careful here. So let's do an example where we have a different situation. And the one we will do is this one. So if I have minus 4x plus y equals 5, and then we have 4x minus 3y is equal to 3. So we're going to have a look at this one. So this is equation 1 and this is equation 2. Now, in this case, if we simply do equation 1 minus equation 2, then we do minus 4x minus 4x. Okay, and if you do minus 4x minus 4x, what you end up with is minus 8x, okay? It doesn't take us to 0. We haven't eliminated the x's there, okay? So what you actually need to do here, because we have a negative and a positive, they have the same coefficient, sort of. They have the same number as their coefficient, but the sign is the opposite. So the top one is negative and the bottom is positive. So what that means is instead of subtracting, we're actually going to add them together, okay? Because if you do minus 4x plus 4x, then they're cancelled out. Then we have 0. All right. So in the next one we have is y minus 3y. Okay. So that's going to give us minus 2y is equal to 5 plus 3, which is 8. Okay. Now we can divide by minus 2. All right. We get y is equal to minus 4. Okay. And then again, it's just a game of substituting. So we have minus 4x minus 4 equals 5. We substituted back into equation 1 here. All right, so minus 4x is equal to 5 plus 4, which is 9. And therefore x is equal to minus 9 over 4. Okay, and because I haven't asked for anything concrete, I'm happy with you to leave it as minus 9 over 4. But if you really want to, you can write that as negative 2 1/4. It's up to you. Okay, so you have to sometimes be careful because if you have a negative and a positive, if they're not the same sign, you need to add them. The other situation, which might be a bit weird, would be one like this. So we could have, for example, I don't know why this isn't scrolling. Okay, so we could have 3x minus 4y equals 7. And 2x plus 3y is equal to 16. Now, one thing I also want to point out to you is you should notice each time that I always have the x's lined up, the y's lined up, the equals lined up, and the constants lined up, the numbers on their own, okay? You need to make sure these are always in the right order, otherwise you can't subtract things, okay? Remember, you can only work with like terms. Okay, so in this example, if you take a careful look at these, you will see that no combination of, you cannot multiply something so that these will have the same coefficient for a variable, okay? So both of these have very different coefficients that you cannot just multiply one of them in order to make sure the coefficients are the same. So in this case, what we're going to do is we're actually going to multiply both equations. If you look at the coefficients for x, you see 3x and 2x. And I know we've been working with x a lot. You don't have to work with x. You can also work with y. Okay, it's just been convenient with the ones we've looked at. All right, so with these two, this is kind of like with fractions. You look for the lowest common multiple. Okay, and the lowest common multiple of 3 and 2 is 6. Okay, so to get to 6 from 3, we do 2 times. So we're going to do 2 times the first equation. And for the second one, to get from 2 to 6 is 3 times. So we're going to do 3 times the second equation. Okay, so equation 1, equation 2. And in this case, we're going to end up with equation 3 and equation 4. Okay, so 2 times 3x gives us 6x minus 2 times 4 is 8y equals 14. And then 3 times 2 is 6x plus 3 times 3, 9y equals 16 times 3 is 48. Okay, and now we have the same coefficient of x here, 6 and 6. So if we subtract these, 6x minus 6x is gone. Minus 8y minus 9y gives us minus 17y is equal to 14 minus 48, which is minus 34. Okay, then we can simply divide by minus 17. Okay, and from that we will get y is equal to 2. All right, and then we're able to solve for x. Okay, and again, with this next step, you can substitute y into any of the 4 formulas that you have created. Okay, in this case, number 2 looks like the nicest, so I'm going to put it into number 2. So we have 2x plus 3 times 2 equals 16. So 2x plus 6 equals 16. Okay, we're going to minus 6 from both sides, so we get 2x is equal to 10. And then when we divide by 2 on both sides, we get x is equal to 5. Okay, so our ordered pair here is going to be 5, 2, and that is the solution to this set of simultaneous equations or systems of equations. Okay, it's pretty nice to do. You just need to get some practice in, okay? But don't forget the substitution method, because you will need that next year. Okay, next year you will be taught both of them. The elimination method is not in your textbook. Okay, it's an extra one that I like to teach you in case you find it nicer.